Welcome back, everyone. Today we're going to continue creating our C++ text RPG, and we're going to start working on the game state machine. So we're going to create the state machine today. State machines or finite state machines are mathematical abstractions used to show change or transition between different states. You can think of it like a car, from going to park to drive to turning to signaling. These are different states that it could be going to. So here's a little diagram. We start with a title screen and we transition to game. And from game, we can go into the menu state and the different options from there, or different selections from there. We can also go from game to battle state and battle to exit. If you die or whatever, or menu, you can also exit the game. So from there, we have different transitions going through. So today we're going to be going through how to create a simple state machine for our game. So now let's go create that state machine. Alright guys, so last episode we created the keyboard class, and we also determined how to process inputs from the console. So today we're going to be creating the state machine. So first thing we're going to want to do is create a new folder, call it states, and in that we're going to want to create a state interface. We'll just call that iState. Shoot. There we go. iState.h. And there. We'll call it iState public. And we're going to need a virtual destructor. And on enter. So this is when we enter the state, and this will be an abstract class, or a pure abstract class. And that's a void, sorry. Void on exit, because we need to show the transition between states. Virtual void update. Virtual void draw. This is for drawing our different text to the screen. Each state will draw its own. Sorry, that's a virtual, not owl. And virtual void process inputs. And we're also going to put another one here, virtual void exit. Or actually, we'll make that bool, sorry. Because if it is exit from a different state, we're going to want to actually exit the game. So not all states will implement this, but all states have to implement this, if you know what I mean. Okay, so we have our state. So now, let's start our state machine. So the same idea, we're going to want to come here. We're going to want to add a new item, a header file. And we'll just call this state machine.h. And here we're going to want to include memory. We're going to want to include stack, because the state machine is basically just a stack that we put onto the stack, put states onto the stack, and pop states off of the stack. And we will be only updating the current stack. And we're also going to want to include state, or iState. Thank you. And we can make right away a type def, because we want all states to be a unique pointer that are going in. Unique pointer, and of iState. This allows for polymorphism. State pointer. Awesome. Class state machine. Now the state machine is a very simple class. It just has a few functions. We want to pop the state, push the state, or get the current state. So private, all we're going to need is a stack of state pointers. So we're just basically have a stack of unique pointers, and we'll just call that m states. In public, we're going to want our constructor state machine destructor state machine. And because we're using unique pointers here, they should all handle their own memory, so we don't have to worry about deleting. And then we're going to want to void push state, and we want to push a state pointer or a unique pointer to new state. And then we want to state pointer. We want to return a state pointer on pop state. Now we may not actually use the pointer that's returned, but since it's unique, once it goes out of scope, it will be discarded. And then we're also going to want to get the current state. All right, so let's create these. So that didn't open, so let's open that. Let's continue creating. Okay, so the implementation of the state machine is pretty straightforward. So let's just initialize our state stack just to an empty state, empty stack. Alright, so there's nothing to do here. We probably could have made this default, but we'll leave it as is. So to push state, it's pretty straightforward. We just want to go m states. I'll keep doing that. M states dot push std. We're going to want to move that state because it's a unique pointer. New state. That's it there. And then we're going to want to states top state. We want to call the onEnter function. This is part of that transition I was talking about before. So when we're going into the new state, we want to run its onEnter function, and then from there it does anything that you want, clear the buffer or create different variables in that nature. So okay, so pop state, another one, pretty straightforward. Pop state is all we're going to want to do is if check to see if it's empty, and states dot so if it's empty, all we're going to want to do is return null pointer, because we don't want to try to do any functions on an empty stack. Now let's go auto old state is equal to std move and states.top. So let's get the top state. Then we're going to want to pop the top. So now that is off the stack. Now we're going to want to call the onExit of the old state. So now if there's anything that you wanted to do, well, then when it exits the current state, then we do call that here. So it could do another thing could be clearing the buffer, or if you do have any pointers or you do your deallocations, everything here. And then we want to return old state. Pretty straightforward function. Get current state is pretty straightforward. And states dot top. We're just returning the top state. So so here we're just returning the top of the stack. There, and that's the state machine. Very straightforward. So let's go try to put this in. Let's see if this works. First thing we're gonna have to do is create a state. Add new item. We'll just call it game state. .h. Game state needs to include iState because it will be a child of iState. So class game state public iState. Whoops. So since iState is a pure abstract class, we need to make sure that we define all of these functions here. So let's copy these functions so we have them. Go back to game state, do our game state constructor, game state destructor, and let's just paste in these functions. All right. So just for testing purposes, we're going to want to include our logger. Whoops. So our build succeeded. Didn't mean to build. All right, you get the point there. So right there we have our game state. Pretty straightforward. This one we didn't really do anything to. It will be changing in the future. So now we're gonna test it out. All right, so for that we want to go to game. Let's go back to game and let's include our state machine. States, state machine. Let's do another unique pointer. And P state machine. Copy that. Go to game state, or not game state, go to game. And right here, initialize this to null pointer for now. And then in init, we want to do the same thing up here. So we created our new state machine, and then now we're going to want to push this new state on top. Before we do that, we have to include game state here. States, game state. And then we're going to want to go MP state machine, push state, new state, std make unique game state and then inside of process inputs we're going to want to call our state machine, but we're going to want to check if p state machine get current state. If not, and B is running, is equal to false. So if we don't have any state on our stack, we just automatically want to leave. We should probably put some type of error here as well. Just for now. No states in state machine to process. Inputs. And we want to call process inputs here. Basically, we want to do the same thing for update as well. No states to update. Draw. No state machine to draw. All right, I think that's it. So we'll go to state machine. We'll go to game state and in process inputs. We don't have a keyboard right now, so let's do that real fast. So we're going to want to send in a keyboard reference, keyboard, forward declare keyboard, private, let's get a keyboard reference and keyboard. Okay. Go back here. And now we have to include keyword. Include inputs, keyword. And then now, on process inputs, we have access to the keyboard. So we're going to want to go if keyboard is just pressed. And we'll just do key escape. We are going to want to... All right, we're going to need the state machine as well. So we're going to have to do the same idea. Go here. We're going to want to go class state machine. I could probably give it a reference to the state machine, but we're not going to. We're going to do it this way. State machine reference state machine. All right, so we have to make this a reference. All right, so if our key is just pressed, I'm gonna go M state machine pop. Oh, it doesn't know what a state machine is, so we have to include state machine. Pop state. All right. So now it should run. No. Yes, I know what the problem is here. Because we changed our constructor here when we're creating a new state in game, we didn't do any of that. So we need to actually send in the reference here. So we need the keyboard. And we need the state machine. So we should actually be in game state right now. If I hit this, sorry. Oh no. Empty. So I found the problem here. I was jumping the gun too fast. So what I was doing is I was trying to check to update the current state or get the current state, and the stack was empty. So I just created another little function here in state machine, const bool empty. All it does is it return if the state is empty. If the state is empty here in game, we're just going to make running false and return. We're not going to want to continue. So now if we hit F5, we put that everywhere. So check state machine empty, state machine empty. If it's empty, then we kick out, and then it should work. So now we go. All right, so we're running right now. Right now we should be in game state. If we hit escape, see, it was updating game state, exit game state. And then since there was no more states, it exited the game. All right, and that's it for the state machine. All right, so that concludes creating the state machine. So next video, we're actually going to start with selector class. And the selector class is very important for us because all RPGs need some sort of selector for moving in the menus and selecting different actions. It's going to end up being a template class because not all the selectors are created equal. We're going to have different data and different situations, so we're going to have to render and select different things at different times, doing in different ways. So we're going to get into that next week. All right, our next video. Thank you. Everyone have a great day. Bye.